Hello friends, welcome to my channel Gate Logic. You're probably wondering, is this another SBC? Well, no. This is a Terrasic DE10-nano. It is a SOC, meaning it has the conventional CPU sandwiched with a FPGA. And I plan to use it in my project. But before I do that, I want to make sure that it is safe for operation. You see, this board is getting extremely hot, and I'm afraid that after investing my time to develop this board, I may have to find out that it burned itself. So what I want to do is first measure and find out how it gets so hot, or why it gets so hot, and how much it gets so hot. Then apply a heatsink and measure again and find if the heat is in control or dissipating appropriately. And if it does, then I'll be more confident in moving forward. So this heatsink is about the size of this Altera chip. What I want to do is put it on the chip. But before I do that, I want to show you how much of a change in temperature it makes as soon as it powers on, and what's the maximum temperature it reaches to while it's in operation. Okay, so what I'm going to do right now is stop my video and let it cool down. And once it's cooled down, I'm going to restart, and I'm going to restart using thermal camera. This cheap thermal camera, it can display. Let me show you what it looks like. So it can display heat signature. It actually is displaying about 37, 38 maximum. This is degrees Celsius. And let me, actually I have a little tripod that I can hook this up. And you can see this nice pattern. It's basically this plastic, and I'm trying to position my camera exactly where I don't get this reflection. This is where exactly where this plus sign is where our Altera chip is. You can see that at maximum I can barely see this. Okay, I want to freeze frame here and just discuss something here. You see, I have this camera. It's recording the infrared wavelengths, and it cannot see infrared passing through this plastic. Somehow this plastic is reflecting that infrared, or maybe this camera is not looking at a longer infrared wavelength. It's probably looking at the shorter end, or the closer to the visible light infrared spectrum. But overall, there should be some emission through this plastic, which I don't think this camera is recording well. So this was surprising to me, so I thought maybe I should point this out. Let's continue. At 40 Celsius. Let me take the plastic off. Now, screwdriver, I'm going to take this plastic off. Let me turn this off before I make a mistake there. So, screw this off. And now, as this was powered off, the temperature should have dropped a little bit. Let's see what the temperature looks like right now. So the majority of the heat is right here. Maximum temperature right now is 35 degrees Celsius. The DE10-nano is not powered on at this time. I've got it in my hand. I'm going to connect this. And there we go. It's powering on. And it's climbing. The temperature is climbing. It's at 44. Turn up. 45, 46. Looks like 45, 46 is the maximum temperature it wants to reach, but I don't see the lights, the FPGA lights. That you see the difference now. With this plastic on, the maximum temperature I could see was about 35. Here I can see it's almost 50 right now. So what I'm going to do is I'm going to stick this heatsink. Take the sticker off.
Place it square on top of this. Turn this into this so you can get some area. Okay.
Alright, I'm going to make another test. Alright, now this time, position it, turn on the camera, and let's plug this in. And I see something is gaining heat signature now. I do have an Altera chip. Let me see if there's anything on the bottom. Anything that gives me any signature that from the bottom it is hot from the bottom. It is hot. 36, 37, it's rising again. How about the top? I have a feeling that this is not a good heat sink. That's why I want to look at the back of it. But overall 38. Overall 38 right now. I can feel the heatsink becoming hotter. Let's connect the cables. Yeah, and this, when I connect my USB, I heard the bing, so Linux is on, everything is functioning. 41 degrees Celsius maximum from the top, and 40, 41 from the bottom. Okay, for now, it's at least 10 degrees less in Celsius. Okay, for now, I think this is doable. And once I have an idea how to remove this heatsink, I will do so. And what I'm going to do, what I'm thinking of is using a aluminum paste to stick this onto the chip. That will be a permanent application, and this will forever stick to the chip. So I want to be careful when I do that. Obviously, I didn't have just one project in mind for this board. I want to make sure that I keep it in a state where I can reuse it for another project. That's it for this video. In the comments, share your thoughts and suggestions, and above all, subscribe to my channel. Thank you for watching, and stay creative.